month working here in NIT Warangal as an associate professor from 2006. So long 12 years and teaching the subject microprocessor and microcontrollers more than 5-6 times here. So it's a better, I think it is a better opportunity for me to share what I know with you. And definitely this course would be different. As usual, this is a new trial, but let us hope this would be success. And this depends upon the participants' interest, how you take these courses. Now, the course is microprocessor and microcontroller, and I'll just give you the overview today. And based on this overview, what exactly is the content of your syllabus, possible we'll try to see. Now, coming to the microprocessor and microcontroller, after completion of this course, what exactly you are going to learn is programmable system. What do you mean by programmable system? The best example is your mobile phone. This system is a programmable, means this you can use to communicate with others, and you can use this for internet browsing. You can use the same device as a torchlight. You can use the same device as a music player, and so on. So you are just changing an option, programming, and then using as another device. So mobile phone is the best example of the programmable system. And after completion of that, this course, you should learn like how exactly the system is designed. And another example of this course, programmable system, is computer. So now if you see the computer, the entire system is built around microprocessor. So how the system is exactly built, how to design a computer, and how to understand the motherboard, all these things you are going to see. Then what exactly the microprocessor is? So now what we do, before going to see what exactly the processor, how a programmable system look like, we'll try to see. So two examples I gave. One is your mobile phone, the another one is your computer. So both are programmable systems. So how to design a programmable system has to be learned. Now, to see that, what we have to do is, we have to see how a microcomputer structure look like. Now let us see that. So now what we do, we will try to take up the overview of microcomputer structure. How a programmable system look like, and based on that, let us view the content of the course. So now what you have to learn is the processor or the microprocessor, which we call, is the key component of the brain, or the key component or the brain of a computer. So we learn about the functions of the microprocessor, and few terminology about the processor like bus interface unit, cache memory, instruction decode, floating point unit, all these things you will come to know what exactly is this. Now, if you try to see the block diagram of a computer, then simply we say you should have a CPU, you should have input and output. So input devices like keyboard and output devices like display. Computer and mobile, both samples you can see. So this is your CPU, which is having the control unit, central processing unit, and whatever you want to do, you are going to write that in the form of instruction in the memory. That is, again the memory is of program memory and data memory. So this is a simple block diagram of your digital computer, and this is called von Neumann architecture. The computer architecture is von Neumann architecture. So more in detail, if you try to see your computer structure look like this, you have CPU and other devices like memory, output devices like printer, monitor, input devices like modem, sound systems, and input devices like your keyboard, mouse, scanner, and camera, and output devices like all connected to the processor through buses with the help of controllers. And now, more in detail, if you try to see, then this is how the first computer look like. Here you have CPU, central processing unit. Don't worry about it, what exactly and all. But this is what your CPU and all your I/O devices, printer, keyboard, video monitor are all connected to the processor through buses. And now we are calling it as a programmable system. And as a programmer, you are going to write your program in the form of instructions in the memory. So your processor decodes the instruction and executes that instruction and performs the task accordingly. So this is just an architecture of how computer structure look like. And can you guess what is the first digital computer is? The first digital computer is ENIAC, which is electronic numerical integrator and computer. The short form is this ENIAC, and it was the first general purpose computer which is programmable to solve any problem. General purpose means that. And now if you see in detail, it contained over 17,000 vacuum tubes before transistors. Vacuum tubes. And you know the size of vacuum tube. And this computer weighted 27 tons. 27 tons. But now we have the computers with 1 kg. Now you see how the advances in the electronic industry, or what we can say the processors and all. And it do 150 kilowatts of power. 150 kilowatts of power to operate this particular ENIAC, the first digital computer is. And the first digital computer look like this. it's, the programming of this, you can see if you want to program, you have to go and change the cable, and two persons can stand beside your in between microprocessor and memory. Such a huge or a big system is that which is replaced now. And here vacuum tubes, your CPU is off. Your CPU is built with vacuum tubes. So now if you try to see the evaluations of the processor, then how exactly and all. So the CPU, we are talking about the CPU, right? So now we said the generalized architecture of a programmable system look like this. You should have CPU, and you should have and I/O devices, input output devices connected to the central processing unit, and then you have memory in which you are going to write your programs. So this is what the generalized structure of the computer. This CPU in which you are going to use vacuum tubes is replaced with an ICs, or we can say a single chip, which is microprocessor. So then the computer in which the microprocessor is acting like a CPU is called microprocessor. So microcomputer, the computer in which your microprocessor acts like a CPU, then we are calling, as we said in the seen in the previous slide, this processor is the brain of the computer, is what we say. So we are using, instead of every time we are calling micro, we are simply calling it as a computer. So what is microprocessor? Microprocessor is the key element of your computer, which we call it as CPU. So that kind of system is microcomputers. So now just see the evaluation of the processors is first in 1971. Intel introduced the first processor, which is of 4004. It is introduced in 1971, and with advances in electronic industry, with the invention of transistors, your vacuum tubes are replaced with transistors, and the number of transistors used are 2250. And this processor worked with 108 kilohertz, and it can perform 60,000 operations per second. And it is a 16-pin DIP, dual-in package IC, and it is 10 micron process is used for fabrication, and it has as powerful as the ENIAC, which had 18,000 vacuum tubes and occupied a large room. Now I have shown you how the ENIAC at that time is. So that CPU is replaced by using this particular IC. So the IC Intel 4004, Intel manufactured this IC, which we are calling it as the first microprocessor, We will see what exactly the processor is, but what is the importance of the microprocessor is what I am trying to explain. So now it's the first processor, and the picture of this look like this, and the layout will look like this. Now this is an IC which is of 16 pin IC is what we said, DIP, dual in line package 1, 2, 3, 4, 5, 6, 7, 8. So this is the first processor which is as powerful as your ENIAC. Then the next processor is 8008, which is introduced in 1972. It is 8-bit processor. It is 4-bit processor. We will try to see what exactly or how to define the word length of the processor, whether it is 4-bit, 8-bit, 16-bit, 32-bit or 64-bit. We'll try to see. Then the next processor is 8080. It is introduced in the consequent 1974, and Altair is the computer built around this 8080 microprocessor, which cost $400 at that time. Then, so this is 8-bit processor, and the technology which you can see here, and the clock frequency 6000 transistors, 1974 is what the year. Then the next processor is 8085. It has few features. We'll try to see these features. Don't worry about it. And these are the evaluations. 8085 in 1974, and you have 1978, you have 8086. In 1979 you have 8088, 1980 80186. So the first computer, which is a microprocessor based, is built in 19, which is around 8088. The first computer, Altair, and for which the Bill Gates wrote operating system DOS. And the evaluation of the processor started. In 8086, Intel introduced 8086 1978, 1979 88, 8186, 286, 386, 486 and 586. So 80586 is the Pentium. So this Pentium is introduced in 1993, and then the computers are built around the general purpose, are built around Pentium Pro 95 to 99, Pentium 2 1997, Celeron 1998, Pentium 3 1999, Celeron 2 2000, and Pentium 4 introduced in 2000. And in 2006, Pentium cores, like two cores working on a processor. Then now we are in the era of i3, i5 and i7 processors. So this is what the evaluation. So what we are trying to see is how the processors came into market and their usage. They are used as brain of the computers. And now we are in I3, I5 and I7. You may be getting a doubt like, and in your syllabus, the processor which is proposed is 8086. But now we are in the era of I3, 2018 we are in. We are using either i3 processor or i5 processor or i7 processor. Then sir, why 1978 introduced processor you are listening now or you are learning now? Why not directly i3, i5 processor? The architecture, if you know the architecture, you know the functions performed by the processor. The architecture of these processors will be very, very complex. But to have an idea how a programmable system looks like, 8086 based systems are introduced in microprocessor, microcontroller, means in microprocessor course. Then you may be having a doubt like, there are so many vendors in the market like Intel, Motorola, and other processors which you have like AMD and all. But why specifically academic institutes will favor Intel? So Intel is not our relative or some kind of thing. Intel stands for integrated electronics. They are not our relatives or some kind of thing. Why we are choosing this processor means Intel maintains upward compatibility. Intel maintains upward compatibility. So what do you mean by upward compatibility? The instructions which they wrote, which are executed by 8086, can be executed by I3, I5 also. The same instruction can be executed by 88, 186, 286, 386, 486, Pentium, 80, that is what we call 80x86 processors. So that is why we are studying Intel microprocessors in our curriculum now. So this is I think whether you are visible or not, but this is how the evaluation is. Pentium 3, Pentium 4, Itanium, and the year it is introduced. This is there in the book, Offenbach, microprocessors by Offenbach. The number of transistors. So Pentium 3 is having 9.5 millions of transistors on the chip, but whereas 8086 has 29,000 and the first processor is having 2,250 transistors. We'll see what exactly this is and the technology used and the package, how they are available in the market. Deep dual in package, both sides pins, PGA pin grid array. Okay, so these are different packages, and the frequency is Intel first processor is 108 kilohertz, but now we are working with i3, i5, which are 2.5 gigahertz or 2.7 gigahertz is what we say, and external data bus width, internal register width, address bus width, and cache is there or not. So these are the details. Don't worry about it. Don't don't get confused or some kind of thing. Each and everything we are going to see in detail. So 8086 is the processor we are going to learn, and your first IBM PC is designed around the first personal computer came into the market with a price of $5,000 to $20,000. Imagine. The first computer came into picture, and the microcomputer structure looked like this. The base, the fundamental component of computer is the processor, and you are going to connect memory to it. So you have different bus slots provided in which you can connect your memory. And the processor works, this is digital device, it works with clock. So you have a clock generator, and you have to do the floating point operations with the help of another thing. And you have to connect your speaker, keyboard, this and all earlier. So all your external devices has to be connected to the processor through an IC called 8255, right? So 8255. And then you should have an on-chip timer, which is 8253. And not only you have RAM, you should have booting instructions need to be stored. To start up a system, you need few instructions called booting instructions. They would be stored in ROM. So this is how the PCXT, personal computer extended technology, which is around 8088 or 8086 processor. So this is how the computer structure look like. Now, what you have to understand here is you have so we just started with what exactly the processor. So in computer, how the processor performs the task, and this is how the personal computer structure look like. So this is based on 8088 now, and these are the details. The moment, see, after completion of the course, if you're going to a shop, then you should specifically ask what you want. I want a computer. You should not say by going home, which computer, what is the processor, what is the memory, and all specifications you will understand by completion of this particular courses. So this is PCXT, which is introduced in 1982, and the features. And the system support chips are these. We'll see what they are. Means here, processor itself is not a system. To make it system, you are adding up RAM, ROM, memory, input-output devices. Additionally, if you want to connect any memory, you can connect it here, and so on. So, microprocessor itself is not a system or a computer. To make it system, we add all the other devices, all other ICs is what we can say. So this is PCXT. Then the next microprocessor is 80286, and then the structure, the next computer is based on 80286, and that is called advanced technology, PCAT technology. So you have the same thing, like you have memory and you have other ICs to be connected to make it as a system, and you have additional extensions. So this is advanced technology, a computer which is built based on a microprocessor which is 8028 6. Then, so these are the PCAT features. Then you have 32-bit processors, which is of 80386 third generation is what we call. We'll try to see what exactly the generations are. And then you have the next family. This is called micro-channel architecture. Your computer architecture is like this. This is what your CPU, in which your processor is working, and you have DRAM, and you have different controllers, and here you have a local CPU. So this is one architecture. Don't get panic. I'm trying to motivate you how these microprocessors are used as computational in CPU. So 80486, then you have industry standard architecture, EISA, or extended industry standard architecture is. So this starts from Pentium, so Pentium Pro, Pentium MMX 1997, Pentium 2, and you have Celeron, so Pentium 3, Pentium 4. This is what's the 7th generation Pentium 4 ICs. Right? So what we understood from all these things is, to your one, microprocessor is used as the CPU or central processing unit of a computer, and the resultant computer we are calling it as microcomputer. So here we have to talk about a law which is called Moore's law. What exactly it says is, in 1965, Gordon Moore, he predicted that the number of transistors on IC will double every year. So we have seen from 2200 something in 4004 to 9.3 million of transistors, millions of transistors in Pentium. So every year, as advances in your technology, which we call it as SSI, small scale integration. Integration means bringing transistors on chip. SSI, MSI, LSI, large scale integration, VLSI, ULSI. As the technology grows, like number of transistors fabricated on a single IC is getting increased, and it is following Moore's law now also. That means what? Every year, the number of transistors are going to be fabricated on IC gets doubles. Later, he modified it to 18 months. With 18 months, it will get doubles. So the processor evaluations and then the number of transistors is what we are going to, or what we have seen this is. So Pentium 4 and the word length, clock frequency, buses, and how to enhance the capability is what we will try to see in these particular courses. So now, what we have seen, so we'll go slowly. So your programmable device, whether your cell phone or your computer is mostly well suitable example, is having a structure like this programmable device. which has microprocessor is working as a CPU, and you are going to connect memory. So that memory also you had RAM and ROM. Why you need two memories for a system? RAM is volatile, ROM is non-volatile. What do you mean by volatile? The moment the power is switched off, the contents of the RAM are getting arrested. But now when you start your computer, Windows is what it is getting displayed. Means to start any computer or any programmable system, two booting instructions are needed. And those booting instructions are going to be stored in ROM or PROM, which we call EEPROM, or E square PROM, double E PROM. So any programmable system should have memory which is of RAM and ROM. You may be getting a doubt. When we have ROM, then why do we need RAM? You can straight away use ROM itself. But there is a term called memory access time. So what do you mean by that? Processor is very fast, working with clock frequencies, kilohertz to, just now we have seen hertz. When it is very fast, your memory also should be very fast, but ROM is very slow. So memory access time of ROM is more. So then to have very quicker or fast system, we should have RAM and ROM. So memory means you should have RAM and ROM, and you will be connecting input devices and output devices to enter instructions and to view the results. So this is how we concluded, like this is what the architecture we call von Neumann architectures. Von Neumann architecture. We have where you have your processor and memory and input output devices. So now I'll define what is a microprocessor. So first of all, we'll try to see what is, we will try to see what is a microprocessor. Microprocessor, micro means small. Small. How much small can be called small? You may be getting doubt. So micro, the moment we say 10 power minus 6. 10 power minus 6 is what? Micron. So here, in generalized terms, we'll try to see micro means small. And processor means which process the data. What do you mean by processing here? Performing addition or multiplication or division or whatever the task. So you will do some task on the data. So we have seen the processor which is very small, on which you can decode the instruction and execute the instruction and perform the task. Everything is done on a small single silicon wafer. So that's why it is called microprocessor. So what is microprocessor? Microprocessor is a general purpose device which can perform arithmetic, logical and control applications. You can define like this. Microprocessor is a general purpose device. It's a general purpose. You can instruct the device to do any task, or you can instruct the processor to do any task by writing instructions in the memory. So microprocessor, how do you define? Microprocessor is a general purpose device which can perform arithmetic, logical, and control operations. So now, with this background, now let us try to see the contents of the syllabus. So what we learned up to now, summarize. Processor, what is processor we have seen, right? And how the system is built around the processor we have seen. We have seen different architectures, like, we gone through these things, right? So how the system is built around the processor is what we have seen. So now, whatever we discussed, it means to make a system, processor is the key role. Then we should learn about the processor, and the processor which we learn in this course is 80. Is not a system. So what we need to do, or a computer, we need to add RAM. We need to add in the sense connect. We need to connect. We will not connect the exact word connect, but we will call interfacing. So we need to interface ROM, RAM, and we need to interface, we need to give a clock, and we need to, you have so many devices here, but each device needs to be serviced. So each interrupt. So then you need to do interrupt, prioritize interrupt. So to make a system, to design, we need to connect all these ICs or connect these things on the motherboard. So we can say this is a small computer built long back. And if you understand the architecture of the personal computer is. So with this background, let us go to the syllabus of your course. Now let us see the syllabus which is designed and all. So now, based on what we have discussed up to now, how your syllabus of this course is framed. Now let us see. Yeah, not study all the processes in a course. So very basic fundamental or the basic processor, which is 8286, is introduced in chapter 1. So here, what you learn is the moment you say the processor related terminology, like what is its architecture, what is, hello, we're going to see the pin diagram. That means how, no, you want to connect, to make a system, you have to connect memory, you have to connect different peripheral interfaces. So then connection means you have to know the pins and its functions. Then only you can connect one pin of one particular IC with another pin of the other IC. So we will try to see the main features, the pin diagram of this particular ICs. And the moment we say the processor or IC, the microprocessor which we are going to see is a hardware. Hardware, what do you mean by hardware? And what is software? You know, electronics engineer, EC engineer is a hardware engineer or software engineer? You'll be saying both answers. He's a hardware engineer and software engineer. So what do you mean by hardware? Hardware is one which you can see and touch. But whereas software which you cannot see and touch. So then you are going to talk about a system which you have both. You have processor IC which you can see and touch, and you are writing instructions in the memory which you cannot see and touch, right? So it is a system is a combination of both hardware and software. So the moment you want to build a system, you have to connect one IC with another IC. So then you have to know the hardware is, right? So you have to know the pin diagram and pin description. And 8086 micro, this family already have shown you 8086, 186, 286, 386, 486, 586, which is Pentium. So its family is what we try to see. And then we are going to see the internal architecture of the processor. That means, what is architecture? The functions performed by the processor can be seen when you know the architecture of the processors. So we'll see the architecture of the processor, and here we will introduce the basic processor 8085 in a day, and then I'll try to give you the concept of 8086. 8086 is a little faster by introducing a concept called pipelining. So this pipelining, that means not only the processor will fetch an instruction, execute an instruction. So it is in sequence process. But if you have a mechanism in which your processor fetches the instruction and executes the instruction simultaneously by having two different hardwares called bus interfacing unit and execution unit. So bus interfacing unit, we'll try to see all these things in the first unit. So that means fetching an instruction, executing an instruction can happen in one cycle, and that's we call it as a pipelining. That is possible because of bus interface unit and execution unit. So then, so this is what we are trying to see, the processor and all, and internal architecture. And now when you design a system, you are going to connect different devices, ICs is which call. Then each device, like input device like keyboard, scanner and all, need service of the processor. So then you have more systems, when you have more devices in a system, then each device can interrupt. Interrupt means what? Can stop or can request, can break a sequence. So that can add up, and that can send a request. So then your processor should able to address all these things. That is through a mechanism called interrupt. So how the other devices are getting serviced with the help of your processor is going to be taken care by interrupts and how your processor responds. That is about interrupts and interrupt responses. And we'll try to see that. So then here basic system means like now you wrote an instruction in the memory. How the processor fetches an instruction and decodes an instruction, how much time it will take. So timing is also important. So 8086 system and how much time it will take for a memory read operation, or once it is executing an instruction, it is writing back into the memory, how much time it takes. So that we'll try to see with timing diagrams. So then that is what the next thing is, what we are going to see in the syllabus. And the next one is the processor can work or can service all the devices, or the moment when you want to do floating point operations, the processor may get slower because it has to do so many operations. So then you can have a submaster, a subprocessor is what we call, and coprocessor is what we call. It can accommodate. So you can work in one environment, one processor can work, or if you can take help of another coprocessor, another processor also it can accommodate. Then we call it as minimum mode of operation and maximum mode of operations. So to make the system performance very faster, how a processor alone can work, which is called minimum mode, and how a processor can accommodate, another processor is what we try to see in the first chapter. So your first chapter is completely about hardware details of the processor, like pin diagram and its internal structure and how it is like performing in a system level, minimum or maximum mode. So that is what is there in the first unit. And coming to the second unit, it is about programming part. So now what we said, a programmable system should have memory, CPU, and I/O. And now you want to instruct the processor to do certain tasks. Then, like if I want to communicate with other person, I can communicate in different languages like Telugu, English, and all. So we know the language. So processor also can be instructed by writing instructions in a language, a particular language. So that language here, the processor which understands the language is assembly language, or in turn we can say machine level languages. So writing your instructions in ones and zeros is a little bit difficult. So then what we do, we write the program in assembly language is. So then we have to know about, like in a system, what are the instructions. See, English language has some words. some number of like 25,000 words or 50,000 words or 1 lakh, like that. Each language will have different words. So then each processor has few instructions which it only can understand. So then we have to see the programming, like, how to program. If it is a system is there, how you can write a program, and then by using which instructions, by using certain instructions, then we'll try to see, like, so instruction, the programming now, like in assembly language you have to write, then all these things you are doing for performing a task means you have to process the data. What do you mean by processing data? Your sensors may be connecting to your device, which is a computer controlled, is what we can say. Then in that case, the data which is sensed by the sensor need to be processed by your microprocessor or controller. Then how to locate data in the instruction is called addressing mode. I repeat, how to locate data in the instruction. Like you will place the data directly, when instruction will perform on the data, or data is stored somewhere in the memory. So how many ways you can write a language? Like, how you want to write a poem, then you have to know the vocabulary, then you have to know the grammar and everything. So this addressing mode is what the next topic we are going to see, which tells us like how to locate data in the instructions. And then every time repeating and proceeding with this data will be a little difficult. So we define assembler directors, we use some directives, and then we mention the data, and we can use those directives wherever we want. So assembly language programming developing tools, like I will be dealing this course through an emulator. An assembly language, the assembler is called, there are two assemblers. One is developed by Intel, which is called MASM, Microsoft Macro Assembler, which is developed by Microsoft, which is an assembler, MASM. So you can do programming in this course by using MASM, or you can do the programming by using emulator. So I'll share. So here the emulator look like this. This is what the 8086 emulator. So all these programs I'll try to write through the emulator, and which is the programming part. Means you are going to design a system, then you have to know how to instruct your processor to do certain tasks. That is what is there in the second unit. Then what is there in the third unit? You want to design a computer, or you want to design a programmable system. Good. But microprocessor itself is not a system, is what we said. So then you need to connect a RAM, you need to connect RAM and ROM, you need to connect a timer, so that to know each, you have your mobile phone, so it has its own timing, like it shows you, it displays the time, right? You have your computer, so that has time, yes or no, right? So you want to provide timing sequences. So you have on a timer, and when you have more number of devices, which device need to be serviced. So that can be dealt with a IC called programmable interrupt controllers. Programmable interrupt controller, which is 8259. So each architecture and how many devices you can connect to 8086 processor through this particular IC, so that each device can be serviced, is what we will try to see in third chapter with an IC code 8259, which is programmable interrupt controller. You have to remember this. Like 8086 is introduced in 1978, and after that, so many processors like 8088, 186, 286, 386, 486, 586. Intel released so many processors, but they are all obsolete. But 8085 processor, which is introduced in 1972 somewhere, and 8086, which is introduced in 1978, are still exist in the market. They are such a popular ICs. There is such a popular processors. So here, these days, when you see the computer architecture, you may not see all the ICs like 8254, 8259, but they are peripheral controllers. They are there in the computer in, you call it as a bridge, north bridge and south bridge earlier computers, but now they are all as a part of processor itself. They are available in the form of processor itself. So it is very complex, but we try to design a simple system by connecting or interfacing 8259, 8254, and similar. You have one more important IC called 8255, which is a programmable peripheral interface. You are connecting a mouse, you are connecting a keyboard, you are connecting a display, you are connecting your pen drive. All these things, additional or external devices to the computer when you connect, then they have to connect through ports. So we'll try to see what is port, how to design port, and Intel, they came up with an IC 8255, which provides 24 port pins. 24 port pins. So this 8255 is used to connect external devices to the processor. So then we'll see that. And then once you have memory, processor, input devices and output devices, then what we do, like sometimes we need to transfer data from your pen drive to the system memory or system memory to the pen drive. Then in that case, if you involve the data transfer by using processor, then your processor will be idle, which is doing this task until your data transfer is getting done. Your processor is idle. So processor time is getting wasted. So then what we do, we use a IC or submaster called 8237, which is a direct memory access controller. So that means you can access the memory directly. So once the DMA, the controller takes the charge, it transfers the data from your system memory to the pen drive. So it makes very fast. So then we need to connect this also to the system 8237. So we are going to see 4 peripheral ICs, 8255, 8254, 8259, 8237 is what it is there in the third chapter. And these days, to build a system, we are connecting LCDs or 7-segment displays, or if you want to process your real-time data by sensor, we need to connect analog to, that means the data is in analog. So computer has to process, that means that it has to be converted into a digital. So the analog to digital converter need to be connected to your processor. So we will try to see how to connect LCD to your 8086 processor. We try to see how to connect a analog to digital converter to the processor and how to connect digital to analog converter to the processors. So this is what we try to see in the third chapter. So what we have seen up to now, we have seen what exactly the processor in first unit, and in the second unit we have seen like how to, we will see how to write program and how to make or how to build a system, how to design a system is what we try to see in the third chapter. So by completion of the third chapter, designing of a simple programmable system can be understood. And now coming to the fourth unit, what exactly the fourth unit is? When you are now in the era of i3 and i5 and i7, then you have to know the advanced processors also, which will improve the system performance. That is done through the next level of processors, that is 80386 and 80486, the computers. When I joined in NIT Warangal, we had computers based on 80486. So I worked, which are floppy disk based computers. So 80486 based systems are also existed long back, but we can understand the systems from how the computers are designed based on the processor. So 8086, 8018, like 386 and 486, the two advanced processors are what we try to see now. It can be with i3, i5, but Intel will not give you the architecture because that is a copyright of them. Yes or no? So they will not release the current run processors architecture. So we have to understand the systems and the system performances by seeing old processors only. You may be getting doubt. We are in the era of i3, i7, then why we are studying these 386, 486, which are long back based systems? But understanding this thing itself is quite complex. Now, that is about the fourth chapter. So once we design the system, how to improve the system performance is what we try to learn in the fourth chapter. And coming to the fifth chapter, that is about 8051 microcontrollers. 8051 microcontrollers. So there, what you do is this. So are you following me? Yeah. So chapter 1, chapter 2, chapter 3, chapter 4, advanced processors when we have seen. Now, to make a system, we are taking, we are building or designing our system around the processor. So now, in a sequence, we have to add like memory IC, that especially RAM IC, ROM IC, and 8255, 8254, 8237, 8259, A2D converter, D2A converter. Each device we are going to connect to make a system. Then these kinds of systems are little slow systems. These are generalized systems. But in few applications like simple toy, if you consider a kid is playing simple toy in your house, so that is based on there no arithmetic operations we need more control operations. So then all these things, if you bring, your RAM should be on chip. You see, if it is outside, then what happened? Data has to transfer from outside world to the processor, which is a little slow. Then what we do? Your ALU, arithmetic logic unit on the processor or the control processor, and RAM on the processor, ROM on the processor, your ports on the processor, your DMA on the processor, your 8259, your controller is on the processor. All these things, all ICs, we bring on one single chip so that the data transfer will be even analog to digital and digital to analog converter also. We bring on the same single silicon chip. Then those kinds of ICs are called microcontrollers. They are called microcontrollers. So what you are going to see in 6th chapter? How to design a system is what you understand up to now. Then once the system is designed, once you know, bringing all these things, prototyping a system will become very difficult. You should get all the ICs that may be available in Kakinada or not, we don't know. Right, like 8255 IC and all. So to build a system, all these ICs you need. But instead, if they are available on single IC, then that would be very easy for you. So then next they came up with next processor. We cannot call it as processor because it has less arithmetic capability, logical capability, the instructions it will do, but more control operations it will do. So that is what it is there in the next chapter. So now, if you try to see the syllabus of your course, the 5th chapter is about means in academic environment we are not favoring Intel, but what I told, they will maintain upward compatibility. So 8051 is the microcontroller. We'll try to see its architecture, its pin diagram, and how the ports are present on chip. If ports are present, then how to program the on-chip ports, and how to, again, here in 8051, these A to D and D to A converters, they are not there. So then how to interface your 8051 with these additional ICs is what we try to see in the 5th chapter. So in 5th chapter, discusses about 8051 microcontroller and its capabilities by seeing its architecture, what features are available on the controller is what we need to see. If features are not available, again you have to make a system. So then, like you want to process, you want to display room temperature on a particular display. This is what that simple task. You have to sense the room temperature and display on some display mechanism. Processed by your controller. So then, but the data is analog, but it has to be converted into digital. Then what you do? You are going to connect A to D converter again to the microcontrollers. On 8051 on chip, A to D converter is not available. Then you have to design a system, how to connect LCD, how to connect A to D, how to connect D to A to a fundamental system which is based on 8051 is what we try to see in the 5th chapter. But what, sir, we are in so advanced technology and all, we have very good microcontrollers are available. So that's why your university introduced PIC microcontrollers in the last chapter, which is 6th chapter. So what are the features of the PIC? That should be an advanced, that should have RAM on chip, ROM on chip, ports on chip, timers on chip, and then you have A to D converter on chip, D to A converter on chip, and this is what the advanced controller is what you try to see in the 6th chapter. So I'll summarize what we have seen, what we are going to see in this particular subject is this. The first chapter is going to introduce the fundamentals or the basics of the processors, 8086. And then the second chapter, how to program this particular processor is you are going to see. The third chapter, you are going to how to connect different devices to the processor and to design a system is what you try to see in the third chapter. And once you design a system, if performance is low, then advanced microprocessors like 386, 486 and Pentium is what you try to see in the fourth chapter is. Right? That is about the fourth chapter. Then here the systems are a little bit slower. They can do generalized, perform any task using your computer, but certain applications you need less arithmetic operations but more control operations like controlling your toy, directions control, car direction control of your simple toy. Then that case, designing all these systems occupy more space, and system will be and it's not compact. So then what you do, if everything is available on chip or not is what you are trying to see, and the solution is 8051 microcontroller, and you try to see how to design a programmable system by 8051 microcontroller is what we see in the fifth chapter. And but still the system designing means again you need to add a D converter, D to A converter, all these things to the controller. Then what we do is, then microcontroller is what introduced in PIC microcontroller. So the syllabus content, and the best book for this is Douglas V. Hall, Microprocessors and Interfacing by Douglas V. Hall is what is preferable, and you can prefer like Butchandi, A.K. Ray and Butchandi is also one more book. And 8051 microcontroller by Ayala is also a good book. And 386 and 486 are best covered in Barry B. Bray, this book, the fourth chapter. Okay, so this is about the introduction of microprocessors and microcontrollers. Be clear with the course. The course is microprocessors and microcontrollers. Going to see 8086, 386 and 486. So microprocessors, and you are going to see two additional controllers too. They are 8051 and PIC microcontrollers. So PIC is one manufacturer, fabricated IC. So that is what you are going to see in these particular syllabuses. So I hope you understood what exactly what you are going to do in these particular courses. Is it all right? So if you have any questions like anything about the course and course content you didn't understand, then you can text me. I think we can go through charts, and I think I can reply. I can see ACET is one college, and then CIST practical is what we can make these courses. Okay, so I introduced what I discussed today. I have discussed today like what is the importance of the processor, where it is used, how the system structures look like, and to design or to understand a computer. See, we engineers, we design computer, not the computer science engineers they design. We design computers. The moment if somebody is asking you, give me an example of an electronic device or electronic system, don't hesitate to tell immediately computer. When you can call a device as an electronic device, can I call this bottle as an electronic device? I repeat, can I call this bottle as an electronic device? No. Any device, can I call this pen as an electronic device? No. Any device, if it is made up of semiconductor, then it is called an electronic device. And if you open a computer and try to see, all ICs you can see inside. And these ICs are made up of what? Silicon. Okay. So a best electronic device is computer, and we are the designers, and we have to know how to design a basic fundamental electronic systems in the form of this microprocessor. So microprocessor is brain or heart of the computer, is what you can say. Brain, yes, it's a brain of the computer, not even heart. It's a brain of the computer is what we say. So with this introduction, I think I have discussed, like I gave an introduction of processor, and then we have seen the content of the course. And in the next class, what I do is I'll try to discuss the pin diagram of 8085 and 8086. So we start the syllabuses. Okay. Thank you very much for listening me. If any problems you are facing, then you can report to university. And I think, little delay I think you may be getting, so I'll try to see that to overcome in the next class. Okay, thank you.